Let's go to the next question. So we are saying for each section, list the course name, instructor name, section name, and the number of students registered. Okay, so look here, in this case, we want the course name, section name, instructor name, and the number of students. Okay, so in this case, what we are doing is bringing in an additional table to the picture. So we obviously have to, since we need the course name, the course table is involved. We need the instructor name, and the instructor and course and section are connected in the section table, so we need that. And then we also need the number of students registered, so we need the registration, right? So we're going to combine all of these tables, sections, registrations, and courses and instructors and students. Okay, so we don't need the students, we only need the instructor name, so that's what it is. The important point to note here is that as I've already pointed out, the tables section and registration have two columns in common because each section is identified by the combination of course ID and section name. Okay, so in the section table you have course ID, section name. In the registration table also you have course ID, section name, and together they connect up the registration and the section tables. Okay, so therefore when you join sections and registrations, okay, you have to join them on both the columns. So we are saying sections S, join registrations R on s.course ID equals r.course ID and s.section name equals r.section name. So you're joining these two on both of those tables, and that's the key point about this particular question. Okay, so here we're saying for each course, list the course name and the total number of students registered for the course across all sections of the course. Right? So here we're not talking about how many students are registered for a section, we're talking about how many students are registered for a course. Okay, so that's the important point, and I'll be showing you two ways of doing this, one which is sort of a roundabout way and a much simpler way. Okay, so here I'm saying select course name count star, and what I'm doing is joining sections to registrations as before. Okay, and then joining courses. Okay, and then of course we are going to group by course name and select the count. Okay, so we are going from sections to registrations to get the number of registrations and then joining it to the course and grouping it by course name, and we're getting the count star. Okay, that's fine. A simpler solution of course is this. We can directly join course to registrations, right? Because registration has a course ID, we can directly join them, and then the problem obviously becomes a lot more easier. Okay, both of these answers are correct, but I think this is the shorter and more precise answer. Okay, question 7, same as previous question, but for courses that have no sections or student registrations, list the count as 0. Right? In other words, for courses that have no sections or eventually the courses have no students, list the count as 0. Okay, so once again we're going to count specifically a column s.course ID. Okay, then we're going to do the same thing. Okay, here of course I'm showing the longer version. I'm adapting the longer version that we had earlier for the solution. Okay, so course name count s.course ID, sections join registrations on both course ID and section name. But finally, when we want to join the course, we say right join courses. Okay, that is because for courses that have no sections or courses that have no registrations, we still want the course details and list the count as 0. So we want to join that, and then we are doing count of s.course ID. Or I could have said, yeah, s.course ID that's the important thing to join on, because a course that has sections but no registrations, would actually I should have said r dot course ID, right? Because the course will definitely not have registrations even if it has sections. So I should have said r dot course ID, then group by course name. Okay, but we can also do the same thing with the simpler solution. I can do courses. I mean, I'm adopting the simpler solution here. I'm just saying courses left join registrations, and then we can group by course name and count it. Count student ID, right? Because student ID is the one which is going to be null if the course has no registrations. Or I could have also said r dot course ID. I could have said that also. That would have also given us the same results, because all the columns from the registrations table are going to be null when the course has no matches. So I could count any of those columns. It would still work fine. Okay, the next set of questions are based on the SBA database, which is the basketball teams, players, etc., etc. Here is the schema. And we'll be using this schema for this. Okay, so looking at question 8, it says list the names of players who have not played in any game. Okay, so this is again tricky. We want the names of players who have not played in any game. Okay, now of course the players are connected to games through participations, right? Because you've got games and then you've got a table called participations to indicate which player IDs have played in which games. Okay, but we want the player names. So obviously 3 tables are going to be involved: players, participations, and games. But what we are looking at is that players who have not played in any game. Okay, but interestingly, what I said is not exactly correct, because in order to answer this question, we can just look at the players table and the participations table. The games table is not really required, right? Because participation tells you which games a player played in. Okay, so what we are going to do is to join the players table to the participations table, right? Because the player name is going to come from the players table, right? But of course, if you do a regular join, then players who have not played any games won't even figure in the join, right? So here what we want is for those players to figure in the result, right? Because if they have not played any game, we want them in the results. In fact, those are the only players we want in the results, right? So what we are going to do is to do an outer join with giving priority to players, but then count only those players for whom there is no row in the participation table. In other words, participations dot player ID is null. Okay, so I'm saying select player first name, player last name from players P, left join participations. We want to give priority to the players table, remember? So that even if players don't have participations, we still want them to show up, right? On participation to player.player ID is participations.player ID. Now comes the most important part of this query. We want to say where participation.player ID is null, right? That is going to happen only for those players who don't have any rows in the participations table. Okay, so this is the operative and important part of this particular query. So this one says list the player names first and last along with the total number of points, assists, and fouls for each player. This is fairly straightforward because the player first name and last name are going to come from the players table. Participations, assists, and fouls are going to come from the participations table. Points, assists, and fouls are coming from the participations table. All you have to do is join them. The only thing that this question illustrates is the fact that in a query you can have multiple aggregate functions. Okay, so I'm saying select player first name, last name, some points, some assists, some fouls from players P, join participations on player ID equals player ID. Group by player first name, player last name, because you want the total for each player. Okay, so this is straightforward. And again, given the fact that the question doesn't say that for players who have not played any games, we don't want anything to be shown here. So therefore, we don't need to worry about any outer joins here. Just a regular join will do the job. This is the question where we are saying, well, for do the same thing, but in the output, show only players who have scored more than 100 points or more and have 20 or more assists. So they should have scored 100 points or more and also have 20 points, 20 or more assists in order to figure, right? So notice that this is a condition we are placing on the aggregate results. Okay, so it will look like this: select player first name, player last name, sum points, assist, fouls. All of this is just like the same before. The join is the same, right? Except that we want to show only those players for whom the number of points is 100 or more and the number of assists is 20 or more, right? So now we want to do a select. Now initially you may be thinking I can add a where condition here. But you have to understand that where condition does not apply to aggregates. Where condition applies only to the basic rows of the tables. If you want to filter individual rows, then you use a where condition. If you want to filter aggregates, then you use having. Right? So when you do a group by and you've got your aggregate function, the aggregates are all calculated. But what we are saying is, print out only those aggregates that meet certain conditions, and those conditions are some points greater and some assists greater than 20. Okay, the key point of this particular question is that you're using having and not where. You shouldn't mix up having and where. Having applies to aggregates. When you're filtering on aggregates, you say having. When you're filtering on original rows, then you say where. Right. So once again, I've explained the logic here. When you download the slides in the PDF, you'll get this logic.